A pleasant afternoon to everyone. I'm Karen and I'll be presenting our technology, the Smart Sniffer, a miniaturized and portable gas sensor array based on conducting nanocomposite with the potential to detect non-condensable gases in geothermal plants. My presentation will be divided into 8 brief parts, starting off with an overview. Some interesting figures about our project. It is carrying two distinguishing names. The first is the working project title, and the second is the project's nickname, the Smart Sniffer. Our research will run for 24 months and is set to develop two gas sensors using a grand total financial assistance of approximately 8 million from the three cooperating agencies, the DOSTPH, EDC, and UST. Research works are being carried out in two sites, the UST Arsenas as the base station and the geothermal plant in Leyte as the second implementation site. Why are we focusing on hydrogen sulfide and carbon dioxide sensing? We're motivated by the fact that our proposed technology has a spectrum of potential users. Zeroing to geothermal plants, we have the operational and environmental sections which can benefit from our product. Non-condensable gases reduce the heat transfer efficiency of the condenser operating pressure, which decreases the turbine power output. Consequently, this leads to higher capital and operating costs for gas removal. These acid gases contribute to corrosion problems in piping and equipment, which pose safety issues. Further, there are concerns in existing monitoring equipment, as mentioned by EDC. We are introducing, therefore, our Smart Sniffer as a promising solution, which could be an alternative device in monitoring these gases. It could promote safety, it could reduce operational cost, and could help comply with the standards set by government agencies such as that of DNR. Here are the general objective and specific objectives of the project. We are following this experimental framework as our guide, where the synthesis and characterization of our conducting composites were done in the first year, and the sequel year is centered on sensor development. For year one, we have achieved the following. We have prepared sensing material components based on conducting nanocomposites. We have thesis students who were enticed to join our research group, and we were able to establish a good relationship with EDC. Year two is devoted more on the evaluation of the gas sensing performance using laboratory samples, checking site requirements for the preparation of the sensor prototype, application of a patent, and making part of the experimental data available for the public through publication and presentation. Here's a representative response of one of the gas sensors being developed towards a model gas analyte, showing a fast response time of 2 seconds. However, the recovery remains a challenge and is being investigated further. As we develop the product, we also conducted customer surveys, of which I am sharing our top 3 aha moments. One geochemist mentioned the need for a complete gas sensing system. A geologist saying that the conventional method is very tedious and time-consuming task, thus an opportunity for the use of our gas sensors. One engineer mentioned that gas sensors may be of assistance if there will be complaints posted by the neighboring communities. Potential impacts to the society and the industry. The utilization of the proposed sensors allows conducting early detection of gases and, when necessary, continuous monitoring so that appropriate mitigation may be carried out before gases such as hydrogen sulfide and carbon dioxide reach alarming levels. Properly maintained environment in an industrial site means safe facilities and healthy workers, which in turn results in better operational costs. We envision that our innovation could be a technological leap for a wide array of gas analysis. Our first target user involves EDC, but we see the potential of expanding to other sectors like the petroleum and mining industries, and even the livestock sector, which we have also considered first prior to the commencement of this project. Before I end my talk, I would like to acknowledge the support of DOSTPH, EDC, and UST, Special thanks goes to my research team. We actually call our group the Smart Polymers and Nanomaterials. On a nutshell, our research focuses on the synthesis and engineering of polymers with materials in nanostate dimensions to produce platforms that may be used not only for chemical sensing, but also for other applications such as wound healing and controlled delivery systems. Thank you, and have a good afternoon.